Today's lesson is more fun with big littling. Okay, you're going to want your G-gallon page for this because this is going to help remember all the different fast facts for your measurement conversions. So, what if I gave you the following problem? How many quarts are in not 1 but 2 gallons? Well, first we should find our fast fact here. We can see that by looking at our Q's, we have 1, 2, 3, 4 Q's in 1 gallon. So we'd need to double that to figure out 2 gallons. So 4 doubled would be 8. 8 quarts are in 2 gallons. Make sure you've got this written down. So one strategy is using the picture and kind of visualizing the double. So you've got the 4 quarts from the first one plus the 4 quarts from the second one, or 4 doubled would be 8. And here's how it works when we big little it. Now I know you might be thinking, on a problem like this, it's such quick mental math. Let's just reinforce this strategy so that when it's not quick mental math, you can do it. Draw your equivalence scale. Put 2 gallons on one side, and we don't know how many QTs, quarts, are going to be on the other side that make it balance. Let's big little it. Looking at the units that we have, we're comparing gallons and quarts. Which is bigger? Gallons. Which is littler? Quarts. Which means that if there needs to be a big and a little on both sides so that it balances out, 2 is little, the question mark must be big then. So we're going from a number that we know, 2, to a number that we don't know. And our pathway is from little to big. So when we go from little to big, and we're working with whole numbers, we're going to use either division or multiplication. Multiplication in this case. We're starting with 2 times something is going to get the answer. So we need our fast fact. Our fast fact is that 1 gallon equals 4 quarts. 4. So 2 times 4 equals 8. So our answer here is 8 quarts. So a couple of different strategies. If you are a visual learner, then you will probably really like to draw out the picture, or at least close your eyes and picture it in your head, and then picture it doubling or whatever you need to do. But our very logical, mathematical-minded people can also draw out the scale and go through step by step. And the big littling tactic is definitely going to work when we get into our next couple of problems. You're going to want to take out your big C, cups, ounces, tablespoons, and teaspoons for this one. How many teaspoons, the little t teaspoons, are in 20 ounces? Okay, well, it might help to zoom in on one of these O's for ounces. And we can see that we have, if we count really, really carefully, we have 1, 2, 3, 4, 5, 6 little teaspoons in that 1 ounce. So our fast fact, 6 teaspoons equals 1 ounce. Okay, so you might want to visualize this. If you're visualizing it, you can see that we have 1, 2, 3, 4, 5, 6, 7, 8 ounces. We'd need at least 1 more cup of 8 more ounces, and then maybe a half of a cup more to get up to 20 ounces. So you could do it that way, or you can big little it. And in this case, it's going to be more efficient to big little it. So draw your equivalency scale put on the 20 ounces on one side and an unknown amount of teaspoons. Sometimes they write TSP, sometimes they just write a lowercase t. All right, it's time to big little it. Ounces or teaspoons, which is bigger? Granted, neither is all that big in the first place, but ounces and teaspoons are the little unit. And we know that because within an ounce, there are 6 teaspoons. They have to fit inside, so they're littler. Because of our balancing scale, 20 is going to be little, and our unknown is big, which means we are going from little to big. So draw that pathway. That means we're starting at 20, and we're going to multiply to get bigger and find our answer. 20 times something. 20 times what? Well, we need our fast fact with our ounces and teaspoons, which is right here. 6 teaspoons are in 1 ounce. So we need to do 20 times 6, which is a lovely, friendly problem for us. I know that 2 times 6 is 12, and I have 1 0 to place. So 120, but 120 what? Teaspoons. 120 teaspoons is the same as 20 ounces. Now we have our big LB for Libra, pound in Greek. So LB is for pounds in Greek. And we can see a whole bunch of O's. In fact, we have a 4 by 4 array of O's, which reminds us that 4 times 4 is 16. 16 ounces in a pound. Now remember, before when we were talking about ounces, those were fluid ounces. That's like in measuring cups and teaspoons and pints and things like that. But now we're talking about weight. So in the lovely country of America, where we do things wacky compared to the rest of the world, our number that we know here is 16 ounces in a pound. And we also know that there are 2,000 pounds in 1 ton. So I'm going to give you a doozy here. This is definitely going to be a challenge. Here it is. A certain elephant weighs about 2 tons. How much would that be in ounces? Okay, so we've got a 2-step problem here, because if we look at our fast facts, we know 16 ounces in 1 pound, we know 2,000 pounds in 1 ton, but we don't have an answer for how many ounces are in 1 ton. However, with this information, we can figure it out. If we know that there are 16 ounces in 1 pound and 2,000 pounds in 1 ton, then we can figure this out. That means that in 1 ton, which is 2,000 pounds, each of these 2,000 pounds is a group of 16 ounces. So this 2,000, they're all groups of 16 ounces. So we could add 16 2,000 times, boring and very inefficient and lots of room for error, or we could multiply 16 times the 2,000 pounds. We'll get how many ounces are in 1 ton. Go ahead and multiply that out. Press pause now. I used strings to figure this out. I knew mental math that 16 doubled was 32, which means that 16 times 2,000 would start with a 32, and then I have 1, 2, 3 zeros to place at the end. So 32,000 ounces are in 1 ton. But this elephant weighs 2 tons, not 1 ton. So we can take this fact, 32,000 ounces in 1 ton, and we can multiply it by 2. We can double it because the 1 ton needs to double to get to 2 tons. Wow! So double that 32,000. Therefore, 64,000 ounces would be another way of naming that elephant's weight. Wow! Your task tonight is the case of the mixed-up architect. You see, an architect got mixed up. At first, he was measuring in centimeters, but then he started measuring in meters, but he forgot to change his blueprints. So they ended up looking like this. How would you calculate the area, length times width, of this rectangle that the architect is trying to build? Think about what you might need to do to convert the units to be all the same unit before you multiply. And when you come up with your answer, is there another way to rewrite it? You also need to find the perimeter of this, which is the outside measurements, like basically if this was going to be a fence. So again, we've got different units mixed up. We've got meters mixed with centimeters. So you're going to need to do some sort of conversion before you tackle the area and the perimeter of this problem. You'll share your approaches and your answers with your discussion groups tomorrow.